Today we're going to be exploring the relationship between square and triangular numbers. We're going to review what are square numbers and what are triangular numbers, and then we're going to investigate the relationship between square and triangular numbers. So first of all, what is a square number? A square number is a number that is the answer of a times table where a number is multiplied by itself, which sounds extremely wordy when I just said it then. Oh, that's a highlighter. Let's go pen. So what is a square number? It is when a number is multiplied by itself. So say 2 times 2 or 2 squared. 2 times 2 or 2 squared equals 4. 4 is the squared number. If we did it again and we said 3 times 3 or 3 squared equals 9. 9 is the square number. Another reason when we're describing a square, why it's called a square number, is because of the shape that it makes when it is arranged as an array of 2 with 2 rows or 3 with 3 rows. So I'm going to demonstrate down here. The first one that we have here, even though it's a single counter tile, if I put a square around it, it is 1 row with 1 column, which equals the square number of 1. If I had to do the second one, I would have 2 rows with 2 columns, 1, 2. My sum would be the number multiplied by itself, 2 times 2. 2 times 2, or 2 squared, because it's a square shape, equals 4. My third would be 1, 2, 3 rows with 3 in each row. 1, 2, 3, 1, 2, 3, 1, 2, 3, worst circles ever. My sum would be 3 times 3, or 3 squared. 3 times 3 equals 9 counters altogether, because it's a square shape. So what is a square number? It is a number that's multiplied by itself, and the answer is the square number. And when you look at it drawn as an array, it makes a square shape. What is a triangular number? A triangular number is a growing pattern. And when that growing pattern is drawn or recorded with counters, it makes a triangular shape. So in the table below, record your arrays. So my first, and these here, first term, my first term has 1 row. 1 row going down, ooh, bad arrow. 1 row going down, and it has 1 in it. So when I add up all the counters, it has 1 counter. In my second term, I draw the first row, or rows that I've done. And then in my second row, I would draw that number again, plus 1, because it's a growing pattern. So I have 1 and 2. Altogether, when I draw that, that equals 3 counters. When I go to my third, I draw the first row, the second row from term 2. I've got 1, 2. I would add 3 counters in my next row because I draw the 2 and then I add 1. And that makes a triangle shape. How many counters altogether in this shape? 1, 2, 3, 4, 5, 6. So my triangular numbers are the sum of a sequence of growing patterns. So for term 1, I've got 1. In my second term, I have 3, and in my third term, I have 6. And this keeps growing. In my hundreds table here, highlight in blue all of the square numbers. So I'm going to my highlighter and making it blue. It's taking me a little bit longer. So I'm highlighting all of the square numbers. 1 times 1 equals 1. 2 rows with 2 equals 4. 3 rows, 1, 2, 3, with 3 columns equals 9. 16, and so on. I want you to count up how many square numbers there are between 1 and 100 and write it just here. Then, in green, highlight all of the triangular numbers. So I'm getting my green pen and I'm highlighting all of the triangular numbers. We established that the first 3 here would be 1, 3, and 6. So I'm going to split this one to show that it is a square number and a triangular number, the number 1. So my numbers are 1, 3, and 6. And then when I finish that, I count up how many I have for the whole hundredths chart, and I write my number here. I answer the question, are there more square numbers or more triangular numbers between 1 and 100? And why do you think there are more of one than the other? In your own words. Using your GeoBoard app, create a square number of 16. Or create the square number 16. So 16 is made by making 4 rows of 4. So 1, 2, 3, 4. 1, oh, this is terrible. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So if you don't have the GeoBoards app, you can just draw an array of 16, which is 4 rows with 4 columns, which equals 16 counters. And if I was doing that in my GeoBoard, I would have a rubber band that goes around the outside of it that looks like that. Inside of this square, you can make other shapes. What shapes can you make? Surprisingly enough, in the next question, it tells you the answer to that question. Find and make 2 triangles inside of the square. Your triangles cannot overlap. They can't share a common wall, and they have to use all of the pegs, all of the counters within the square. Describe the sum that you would use to create the number for the square number. So our sum would be 4 times 4, or 4 squared, equals the square number of 16. What would our 2 triangles look like? What sum would you use to describe these triangles? So we've got 2 consecutive triangular numbers. So we have our square number sum here, and then here we've got our triangular numbers. It's made with 2 triangles. Our numbers are counted by counting how many pegs are used in that triangle right there. So here we have 1, 2, 3, 4, 5, 6. So our first number would be 6 plus, now I know it says 10, but we're just double checking. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10th peg is right in the middle there. So you have to count all the pegs inside of your triangle as well. So 6 plus 10 equals 16. So we go back over here. We have 6 pegs in our first triangle and 10 pegs in our second triangle, which equals 16. So this time make a square with 25 pegs on your GeoBoard or draw it in your books, 5 times 5. Create 2 triangles within the shape. The triangles, like before, should not overlap and it shouldn't share common walls. Do the numbers in the triangle represent a triangular number? Let's see if the previous one did. 6 and 10. So 6 is one of them. Let's see if 10 is also. So in our fourth, here's my first row. My second row has got 2. My third row has got 3. My fourth row has got 4. So 1, 2, 3 rows. 1, 2, 3, 4 rows. How many do I have altogether here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I had to make my fifth, I would go, here's my first row of 1, 1, 2, adding 3 to the third, adding fourth to the fourth, and then I'm adding a fifth row. 1, 2, 3, 4, 5. So up to now I have 10, then I add an extra 5. 10 plus 5 equals 15. So in this pattern here, I start with 1, and then I add 2, and then I add 3, and then I add 4, and then I add 5, and over here I would add 6. I don't even need to draw the pattern. I just add on the next number in my growing. So 15 plus 6 equals 21. So if I had the 6th growing pattern, it would be 21. For the 7th, I would add 7. So going over here, we're highlighting our triangular numbers into highlighter. Double check that it's in green. So the numbers that we had here are 1, 3, 6, 1, 3, 6, 10, 15, 21. 10, 15, and 21. So our initial question is, create the two triangles in the square, don't overlap them. Do these numbers 6 and 10, are they triangular numbers? 6 and 10? 6 is a triangular number, 10 is a triangular number. So, yes. Yes, they are, my friend. Then complete this equation to check the rule of two consecutive numbers to make a square number. So, yes, 6 and 10, yes, they both are, triangular numbers. But then we go ahead and we ask, are they consecutive? Do they go in a row? So, if we had 1 and 3, they would make a square number of 1 plus 3 equals 4. That would be making a square number. So for 1 and 3 would be the consecutive numbers, 4 would be the square number. The one that we were looking at before is 16, the square number of 16. Could it be made with 6 and 10? 6 and 10, they come one after each other, so they're consecutive. And do they make a square number? Yes. So let's test out another one. What if we went 3 and 6? 3 and 6 are consecutive here. So 3 and 6. So we have 1, 2, 3, 4, 5, 6. So that's like the geoboard triangle here. And then we need one with 3. 1, 2, 3. And that makes a total of 9. So does 1 plus 3 equals 9? They're consecutive. Here's 3, here's 9. They come in a row. And does it make a square number? Is 9 a square number? Yes, it is. Having a look over here for 25. So we've got 25, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. These are the worst triangles. Circles count as ever. However, can you make two triangle shapes here? So we could make one here, and then you could make a second one just here. So how many in each triangle? And if we double checked how many are in each one, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 in this triangle from the 25. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 10 in this triangle. Are 10 and 15 both triangular numbers that are right next to each other on the hundreds board? You'll have to check out the answers that you populated earlier. But my answer would be yes. Yes, they are consecutive numbers. And yes, they do make a square number. So my new rule would be 10 plus 15. My rule could be two consecutive triangular numbers. When added, will make a square number. Go through and check by completing this table. So, write the smaller triangular number, a larger triangular number, add them together, and check to see if it makes a square number. Does this prove the statement? You can check this by going against the hundreds board that you made previously. So our next one would be 15, because you can see 3 is taken from here and added to the next row. 6 is taken from here and added to the next row. The next number along next to the 6 is 10. 10 is taken from here and added to the next row. The next number next to 10 is 15. 15 is added here and put into the next row. 15 plus what equals the next consecutive number? Then, when you finish that, does this prove the statement? So 15, and the next one would be 36. Does this make a square number? Then 36 goes to the next row. Does it make a square number when you add the next consecutive number next to it? Yes or no? Write a statement to explain the rules or the results that you found. Then, when you've done that, solve this riddle. So, 7 times 7 equals 49. 49 equals an A, so I go across here and I put an A where it says 49. Answer the numbers for the missing numbers for the square number riddles and for the triangular number riddles. It will make a word here after you've populated your answers. Find a pathway for Fred the frog to reach the lily pad. Here's Fred the frog. Here is our lily pad. Fred can only move vertically and not horizontally. Oh, sorry. Fred can move vertically and horizontally, not diagonally. Oh my goodness. So vertically, horizontally, but he can't move diagonally. Calculate the color tile. Only color tile squares that are divisible by 7, 9, or 11. Then do this puzzle here. How many triangles can you find in this shape? And you finish today's maths lesson.